Right, we're in lesson 31, I'm right?
Yes,
32.
no, 32.
Lesson 32. We are busy on trig graphs. The trig graphs will help you with the rest of the trig. You started off from grade 10 where you actually knew the trig graphs. You know your what graphs?
Mother graphs.
Mother graphs. So if I ask you to go sketch these now, these are the new transformations. Grade 11 of grade 10, you were stretching and shrinking vertically. You were moving up and moving down vertically. But now this here, there's horizontal shifts and transformations. Of which this one says you must do what? So take every value of x and divide it by 2 because of the girls, right? The girls which are always backwards. This is also a girl story because the x minus 45 says we're going to go
Plus 45.
plus 45. So we're going to add 45 to each and every one of them. So in the tan graph, we're going to take x and we're going to plus it with 45. In this graph, we're going to divide by 45. And the rest stays what it was. The original points that I taught you. And now I did say go to minus 45 and go only up to 315, but you can always erase and draw it longer. So for instance, I just asked for the negative side, then you would have to apply that to the negative side. But you start off with these 5 points for cos. So the first one is, if you take your x value of 0 and you divide it by 2, you still have 0.
Yes.
Where are you still?
0.
Okay. So that's 0, the answer was 1. Now the x value must just be divided by 2, which is still 0. This x value divided by 2 will give you 45. So it's going to go through 45 instead of the 90. The third step, the third point. At 180 it's negative 1. Now it's not 180, it's 90 that's negative 1. Can you start seeing the pattern? Yes. Because all of them is now divided by 2. So there's your cos graph already growing. Ready to curve up again, going back there, going back there. And with all of them you can do the same thing. 270 will now be 135. And 360 will now be 180. And we curve. And we curve. Alright, that might be a little bit too much, but okay. And then what about the rest? You can't stop. So it's going to go to 225. And then it's going to go to 270. And then I stop. Because they told me so. Remember that these graphs continue up to infinity and negative infinity. You must just graph them or I give you the domain, the x values that you're allowed to work with, because in essence, you can go everywhere. On the left hand, let me just complete that. So on the left hand side, what is the continuation of that? 45 and 0. And then I stop.
Yes.
So if I do this in an exam and I make it a little bit longer here and a little bit longer there, you don't allow to go on there because I said stop there. And then we must punish you. You don't listen to what I said the domain was. Alright, so now I've made G my yellow graph. And I'm going to make F an orange graph so that you can all the time see what's going on here. And the same thing will apply when we get to parabolas and hyperbolas and all the graphs. Using color helps. So if I do the tan graph, I go to the mother graph, and what do I do with every single of these points that I know of by heart?
Minus 45.
Okay, so you can start with the asymptotes. It's always a good place to start with the tan graph, so you can see where's your barriers.
Yes.
So this barrier will not be at 90 anymore, it will be at
45. Really?
135.
Oh my gosh, even the asymptote.
Right? And the next one was at 370. That'll now be at 315. And where was the previous asymptote? It used to be at negative 90 and it's now going to be at negative 45. So from 45, because it moved to the right, plus with 45. To the right, plus with 45 is 135. To the right, plus with 145 with 45 is 315. So there's my orange barriers, like the matrix. Alright, then we're going for our tan graph, and each and every one of those points must now also move 45 to the right. Remember the girls? It says minus 45. It's going to go plus side. Adding in. So where's this point going to be? At 45. On the 0, right?
Yes.
And the next one should have been at 45. It's now going to be at 90 and 1. That one will still say 1, but now at 90 and 1. You see it curving already? How must I curve this? Upwards. Right. And then on this side, can you already figure out where this will be then?
Yes.
The next one should have been at 45, negative 45, and negative 1. Now it's going to be 0 and negative 1. And the shape must be perfect. It can't be skew because you're doubling and whatever, it's going the wrong way. So that it goes down and up to infinity here next to the asymptote, but never cutting. There's a perfect tan graph. A perfect tan graph. Right, so for the next one, let's do it this way. Where will this 135 one now be? At 180. So at 180 it's going to be at negative 1. At 180 it's going to be at negative 1. And once you've got the pattern, you can just continue the pattern all the way.
Yes.
Right? So the next one would have been this point, which was at 180. At 180, and it's now going to be at 225. This one used to be at 225, it's now going to be at 270. If you're feeling, oh no, 270 is an asymptote, remember the whole thing shifts, including its asymptotes, part and parcel of the package. Right, so, and then the graph again, it's not a straight line, it curves upwards and it curves downwards. We talk about concave downwards and concave upwards, so it changes in that point. We call that a point of inflection where the concavity changes. That's for next week. And the same thing on that side. But what do I have there? The next one would have been at 315, right? Now it's going to be this point at 360. It's going to be negative 1. And going down, yes, I know you want to stop me and you're quite right. And it would have looked like that. But do I sketch that? No. Okay, but that's how I would have sketched it if I could go to 360. Stop. If I could go further, it would have been the next one at 405. It would have been, but you stopped where I tell you to stop, and that was there. So, erase. Are you with me? But point by point, you take them to the right. And on the left, we finished already. And this is the one that we call F, the orange one. And there's nothing there. So there was just two perfect tan curves. Right, let's go to the questions. Because we're going to do a few of them now so that we can get into the hang of it. You already did this last year, quite a few of them.
Yes.
What is the amplitude of F? Now please realize that F is the tan graph. Don't ask me, or don't answer me for cars if I'm asking you for tan. So F is the tan graph, and I'm asking you for the amplitude, and that is? No. Now, since we are busy with practicing, guys, what I'm going to do is I'm going to give you a paper like this where I'm going to give you all of this writing that's over there all the time. So you're just going to put it in. So sometimes this I would think, I'm not going to put this in a paper, in a question paper, because it's silly to ask for the amplitude of a tan graph. But if it is asked, then you just say there isn't one, or it doesn't exist. Amplitude of G? 1. And where do we normally see it without sketching it? There in the front of the cos. There's the 1. There's the amplitude. Right? And it's marks forever. What is the period of both of them? The period for the tan graph?
315.
Period for the tan graph is 180. Did it change?
No.
When the graph moved to the right. Everything moved to the right, but as is. It didn't do anything like this. It just picked it itself up and moved to the right 45. So it's still going to be 180, like it was in grade 10, because nothing was stretched or shrank. It just moved to the right. Period of G?
157. 215.
There is a perfect cos graph. And it took it from 0 to 180. So what's the period? 180. But yesterday I showed you as well. When you look at it like that, you think all the x's are divided by 2. In general, a cos graph period is 360. So I showed you to then say 360. Also divided by 2, which gives you 180. You don't have to show me that, but it's the essence of it I want you to see. Everything squished. All the x's was divided by 2. So the period to make a complete graph. Now guys, also it's going to happen to you that I might say only sketch this part of the cos graph. So there isn't even a complete cos graph. But what is the period? It's still 180. Even though I just have 3/4 of a graph there, it's still 180. Even if it's not finished, it's still going to be 180. I might give you a graph like this I'm going to. It stretches like that. So it's not halfway finished even. Then you're still going to have to tell me that the period is whatever you do to the x's. There's nothing done to the x's. Cos will be 360, sin will be 360, and tan will be 180. But if something's done to the x's, whatever you've done to the x's, you also do to your period. And you can see it. Do you see a complete cos graph from there back to their little bucket? Right, let's go on. The domain. Let's get back to grade 10 where we said domain and range. How were you taught to remember that?
Domain is all x values.
Domain is the x values. How were you taught to do that? D comes before R, domain range. Alright? So x comes before y. So that's why the domain is all the x's. But what are the x values? Silly question. Actually, it's everything you use. If I don't give you a restriction, what is the x values? All the real numbers. But for this one, that's actually always your domain. So your domain would be from an element of -45 up to. And you remember when we were writing this in algebra, you could have said x is between -45, which I personally am a fan of, and that's not quite right because it must be included. And who's right? Both. Right. Domain. So now I'm going to change that and I'm going to make it the range. Let's make it the range because that makes much more sense to ask that question. What is the range then of G? G being the yellow graph, the cos graph. The range is all the y values, and the y values used in that yellow one is up to 1 and up to. How do we write that? All the y's? Like that, because I like it that way. Or you write it that way. Perfect, no problem. In between? 1. Always the least one on the left, the more one on the right, and included, because both of those points are included. Nice and easy? Right? Minimum and maximum. Minimum value of f being the tan graph. Minimum value of a tan graph doesn't exist. Nice to practice here, but not in an exam. Doesn't exist. Or there's none, or whatever you'd like to write there. Maximum of G is 1. Now this is too much. I'm asking the same thing twice actually if I ask range and maximum. So I'll ask one of the two. I won't ask all of this in one test question. It's too much. Now comes the rest of it, which you also did last year, and I know you loved it because you didn't get it right always. Even with the parabolas, even with a parabola in a straight line, I could ask you, what am I asking you? Where they equal. Where they intersect. But listen, estimate your answers because you're going to go to your graph now. And you are not going to be 100% accurate because depending on how curvy you feel, you're going to make it bigger and fatter and bigger and fatter. Are you with me? So they might not be on exactly the same places. But where are these two equal to each other?
45
45
and 25.
X equals 245 and 225. And we'll continue with that tomorrow.
Ja, hij is